Alright, we're finally on to our first example. Please find the vertical and the horizontal asymptotes of this example. Pressing pause, and when you're ready to see the answer, press play. And we'll use those vertical and horizontal asymptotes in a second in order to graph the function. Okay, hopefully you got x equals 4 and x equals -1. And for a horizontal asymptote, you got y equals 2. We want to rewrite those again. After you find the asymptotes, let's talk about how to actually graph the function. I'm going to graph these asymptotes first. X equals 4. And x equals -1. And I'm also going to graph y equals 2. Now what I'm going to do with that is I need to find some points, and this really is the last bit you need to know. I need to find some points so that I can find out where the lines are going to be graphed inside of each little box. You'll go back to way back at the beginning of the video when I showed you the first example. You notice there were 3 segments. This one's going to have 3 segments also. Okay, I've gone ahead and changed the display just a little bit to allow me to bring up a graphing calculator. Now, I know you may not have a graphing calculator at home, but I'm just going to show you the process I'm going to use in order to find the ordered pairs we need on the graphing calculator. First, we're going to go y equals. So we go to y equals, and we're going to type in the entire top of the numerator. But notice I have a 2x squared plus 2. I want both of those things to be in the numerator, so I'm going to put a parentheses around them. 2x squared plus 2. Parentheses. Divided by, since I have 1, 2, 3 different terms in the denominator, I'm going to put parentheses around that as well. X squared minus 3x minus 4. Then I close my parentheses. Y'all, to find our ordered pairs, we're going to go to second, graph, or to table. If you're tempted to, I just want to show you this real briefly. We're not going to use this much. You could go to graph and notice that it kind of sketches out the asymptotes that we found. 2, -1, and 4. Although it's not entirely reliable because the calculator has a hard time finding those values. Okay, let's go ahead and go to the table. Second, graph. And all I'm going to do is I'm going to find a few points in each sector. In other words, -10 to -1. I'm going to graph a few of those points. So it looks like I got -10, 1.6, so -10, 1.6, somewhere about there. Let's pick another point, -6, 1.48. So again, right about in the same area. And -4, 1.4. So again, we're just staying in the same area right here. And that's again why it is a horizontal asymptote, because it's flat right here. Those points are going to disappear just for a second while I scroll down and find a few more points. Alright, we've got -2, 1.67, so -2, 1.67. And I'm going to move the calculator. Zero, -0.5, so 0, -0.5, 1, -0.67, 2, -1.67, and 3, -5. And again, the points have to disappear for a second. And I'm just going to pick a few values out of that next section. 5, 8.7, so 5, we go up to 8.7. Just pick a few. 8, 3.6. and 10, 3. So we're going to use those points plus, let's go back to the graph to show us how to connect the points. I know my graph's on top of the points for the second. See if I can move that over a little bit. Okay, and we notice over here it goes over through those points and then it's going to go up to the asymptote. So I'm just pretty much sketching a graph based on the picture on my graphing calculator. This one goes up across this asymptote and then back down, and the last one goes down through this point and then down here. And that's all it really is going to be required of you in order to draw your rational function. The last thing we want to talk about is the domain and the range, and that's a little bit more difficult. Really all you're going to be required to do is to find the domain. And the way we're going to do this is I'm going to tell you that the domain is all real numbers except, so I'm going to allow you to write x cannot equal our two vertical asymptotes. X cannot equal -1 and x cannot equal +4. So again, in order to graph, you graph your asymptotes, you find points from your table on your calculator, you connect your dots based on your graph, and then to find the domain, you just write down that x cannot equal those few values. Notice the x can be anything but those, anything but -1 and +4. Okay, now we're on to our first example for you to work mostly on your own. I understand you don't have a graphing calculator, so you're going to get to use the points from mine here in a second. First, I'd like you to pause the video, find the vertical and horizontal asymptotes, and graph them. Okay, hopefully you found the vertical and horizontal asymptotes are x equals 0 and y equals 0. We really don't have to draw those since they are the axes themselves. If you have a calculator of your own, hopefully you turned it on, pressed y equals, and went to your table to find some points before and after your asymptote, which was at 0. So I've got some points here, and I want you to go ahead and graph those points, then connect them with the lines that create a graph looking like this. I'll show you that again in a second if that was a little confusing. So right now, just go ahead and graph those points. Okay, here are your points. I'm going to show you a graph here in a second, and I want you to connect those points matching the graph on the calculator. Alright, there's the graph on the calculator. We're going to match those as best as we can. Looks like it goes over, dips down a little bit, and then comes up and gets close to the asymptote. And over here we're going to go down and get close to the asymptote on that direction as well. And there you go. Let's find the domain. Again, for the domain, I'm going to let you write just what x cannot equal. So it's all real numbers, forever to the left and forever to the right, except for 0, because we have a vertical asymptote at x equals 0. Right, I've got one more example for you to work after this one. I'm going to work it in the same sort of way, so go ahead and get ready. Alright, work this one in the same way as you did the last one. Find the vertical and horizontal asymptotes, graph them, and then when you're ready to see the graph actually on there, go ahead and press play, and I'll show you the table so you can find some points to graph, and then we'll graph the lines together. Okay, hopefully you got your vertical asymptote to be -2 and 2, and your horizontal asymptote, there wasn't any, because the degree of the top was 3, which was bigger than the degree of the denominator. Alright, you hopefully typed in your equation if you have your own calculator, x to the third. Notice I put parentheses around it. Minus 2x divided by x squared minus 4. And we go to our table, and we're going to assign some points before and after -2. So I'm going to do these in two chunks. The points before -2, the points after -2, and then the points after +2. So go ahead and graph those first, and then I'll show you the points after 2, and then we will show you the graph. Okay, I went ahead and graphed all the points. Now you see those points. Let's take a look at the graph. And this one's a bit interesting because if you look at the graph, you'll notice the points come up from the bottom to -2. I forgot to draw my asymptotes. That was a really bad asymptote. -2, +2, and so it comes up towards that asymptote and then goes down. This one right here, it does something weird. It looks like it goes down, dips up, and then goes back down again. Alright, this one right here goes down and then up. Alright, our asymptote, or our domain rather, is x cannot equal 2 or -2. And that's it.